Great. Hi and welcome, everyone. This is the Aave Devs 101 workshop, and joining us today is Emilio. With that, I will hand it over to him to introduce himself and kick the session off.
Okay, perfect. Thank you, Emily. Thanks, ETHGlobal, to have us today. So I am Emilio Frangella. I am the lead smart contract developer of Aave, and essentially I am one of the guys that actually designed and built the Aave protocol, which it has been quite an adventure until now. In the last couple of years, the Aave protocol managed to become one of the most relevant DeFi protocols with TVL and assets under management that rival with other actually full networks like L1s. So we are pretty happy of how everything has been working so far, and the protocol has been progressively being owned by the community. So right now the community is also participating, also building the protocol. We have an Aave grants program that actually is allocating funds to projects that contribute to the Aave protocol. So everything is going really well, and hopefully this will be a nice introduction for you guys to start using the Aave protocol, start interacting with it, and understand how it works and what you can actually build with it. So let's start. I guess everyone knows what the Aave protocol is, but I will just give a brief introduction. So the Aave protocol is what we call a liquidity protocol. So it's a set of smart contracts that is actually able to interact with users. Users are usually classified in depositors and borrowers. The depositors actually provide liquidity in exchange for earning passive interest, and the borrowers are usually also depositors that they leverage their deposits as collateral to borrow a usually different class of assets. So a borrower is, first of all, also depositor. This means that whenever you replace collateral, you deposit collateral in the system to borrow a different asset, then your collateral is also earning interest in the meantime, because it's being borrowed by someone else. And so you are, first of all, a depositor, and then like you can all your deposits acquire a certain, depending on the category of assets, they acquire a certain borrowing power. And then with this borrowing power, you are allowed to borrow a different category of assets, for example, stable coins. And of course, like you will be required, your deposit will remain locked in the Aave protocol until you repay your debt. And repaying your debt means repaying the principal of your loan plus the interest that has been accumulated over time. Repayments don't have any particular time schedule. Repayments don't have a fixed interest. So the interest is algorithmically calculated on chain. So it depends on how much liquidity there is available on the protocol, and it varies all the time depending on who is depositing what and who is withdrawing what. And so, as I mentioned, there is no repayment schedule. Therefore, the loan can last 1 second, or the loan can last 100 years. There is no, as long as your collateral covers the debt plus the interest. Okay, so main actors will more or less already described like the usual behavior. Then other actors interacting with the protocol are the price feeds. That is Chainlink. Actually, the Aave protocol uses Chainlink to interact with this critical part of the ecosystem, which is price discovery, because of course to calculate borrowing power and to allow repayment and liquidations, it's a fresh and a frequently updated price feed is needed, which is currently provided by Chainlink. but the Aave protocol can potentially support other classes of price feeds. And then, of course, liquidators. Liquidators are another actor that usually take care of repaying the debt on behalf of borrowers and getting part of the collateral in exchange when the price of the collateral drops too much. Usually, the liquidators get an equivalent amount of the debt in collateral plus a bonus that will essentially guarantee that liquidators are actually able to sell the collateral, and they actually have an incentive to do it. Liquidators are, of course, critical to keep the health of the protocol in check. And then, of course, we have a variety of integrated applications that use the protocol in different ways. They provide like aggregated yield to their users. They provide a different user interface to access the Aave protocol. Then we have smart wallets. We have leveraged systems like, for example, DPI building. DPI is the DeFi Pulse Index, building leveraged tokenized positions on top of Aave, and a lot. We will see at the end like there are over 100 different protocols and applications built on top of the Aave protocol. So, as I mentioned before, the protocol grew pretty quickly. The slide is actually reporting 15 billion, but the slide is slightly outdated because the current TVL is actually 25 billion. So it's like growing really fast. The Aave protocol has also the ability to host a variety of markets on different networks or with different assets capabilities. Right now, there are 4 markets available. The V1, which is actually the version 1, the set of smart contracts that were part of the Aave protocol version 1, which is now obsolete, and people is slowly migrating to the new protocol iteration. Then we have Aave V2, which is the current protocol iteration, and is like the market that hosts the majority of the TVL, around 12 billions. Then there is an AMM market, which it was an experimental market where users are actually able to use automated market makers LP shares as a collateral to borrow stablecoins. And then we have the Aave market on Polygon, which essentially guarantees the same features of Aave V2 on Ethereum, but with the advantage of very, very low transaction fees on Polygon. So of course, like right now, the market with the highest TVL is V2, but the Aave market on Polygon is actually the market which has the highest number of daily users, around 4,000 users a day. Again, a recap of the main protocol features, like the deposits, the borrow, then the credit delegation, the flash loans, and then there is also a short introduction to the governance if you guys want to build something to integrate with the Aave governance. So the deposit. Deposit is the first usually the first interaction that a new user performs with the Aave protocol, which means that the user calls a specific function that is called deposit and executes essentially this function. The user, of course, like in this example, this is explained here. If you want, for example, to deposit 100 DAI, you will, of course, need to have 100 DAI in your wallet and have approved the Aave protocol to take 100 DAI out of your wallet. When you do the deposit, you kind of receive a receipt that is called in tokens, that is called a DAI. A DAI is essentially a representation of the DAI that you deposited in the Aave protocol, and it's as the peculiarity compared to other liquidity protocols. This is one-to-one with underlying. So you deposit 100 DAI, you receive 100 A DAI, and the amount of A DAI that is essentially the interest accumulating over time increases over time in your wallet directly. So like by looking at your wallet, you can already see that the interest is actually growing. And the accumulation happens every second in a complete algorithmic way. So here there is an example of Solidity, a Solidity example of interacting with the DAI and the Aave protocol. You can see the address of the DAI token, the amount that you want to deposit, $100 multiplied to the power multiplied by 10 to the power 18. That is the number of decimals that DAI has. And on behalf of the referral code are two other parameters. Referral code, like the protocol has the potential to have a referral program. So for people building on top, like the governance can decide to allocate, for example, part of their funds to promote the usage by associating referral code with applications that provide usage. And then on behalf of is used because you can eventually call the deposit on behalf of another address. So for example, imagine that you have 100 DAI on address X, but you want to receive your A DAI on address epsilon, then you can actually deposit with call the deposit function with address X, but put on behalf of address epsilon, and then you will automatically receive your A tokens on address epsilon instead of address X. The withdraw is essentially a opposite interaction compared to the deposit, and it allows you to redeem A tokens for the underlying. So whether or not you deposited or you received A tokens that are of course transferable, like a DAI in your wallet because someone else transferred to you, then you can always redeem them for the underlying by calling the withdraw function. There are some, how can I say, there are some things to keep into account when doing the withdrawal, especially like sometimes the withdrawal can fail if there is not enough liquidity available. This is usually an edge case. That means that there is high demand of the market for borrowing. But I think we can further discuss about this later. And then we have the borrow interaction. As I was mentioning before, if you have deposited assets, you can essentially borrow any other assets that you might need. And you can also borrow in two different interest rates mode, which is variable or stable. Both are algorithmically decided, but the variable changes per second, while the stable, or per block to be more precise, and while the stable rate is usually stable in the sense that doesn't change so often, can only change depending on the particular states of the protocol. I think we can also discuss about this a bit later. Of course, like the total collateral and the total borrowing power is the sum of the borrowing power of each independent asset that you deposit in the protocol. So imagine that you deposit ETH, Rapid BTC, and Uni. Then like the protocol will automatically and on-chain aggregate the total equivalent amount of the assets you deposited in ETH. And from that total equivalent amount, calculate what is your average borrowing power by doing the average of proportion, the weighted average of all the assets that you deposit. As I mentioned before, you can repay whenever you want using the same asset you borrowed, or you can even there are some functionalities that were built on top by Parafai, for example. You can essentially use your deposits to actually cover the position by using Parafai to sell your collateral in one transaction. Yeah, when you open a borrow position, so you deposited some collateral, you decided to borrow stable coins, and then of course, as we all know, the price of the collateral fluctuates over time depending on market conditions, right? So how do we determine if the collateral is enough to actually cover the debt at all times? There is this indicator that's called LFactor. When that factor is less than 1, essentially you will be the position will be liquidated, which means that liquidator will actually invoke a specific function on the Aave protocol to repay the debt in your behalf and receive part of your collateral plus bonus. Of course, if you get liquidated, you lose the bonus. So people that is borrowing is usually very careful about keeping the health factor as high as possible. So it's a matter of evaluating the risk reward of keeping your health factor low enough to maximize your borrowing potential, but also high enough to avoid a liquidation risk if the market drops. Something happened here. Okay. Okay, so if we keep using the example that we mentioned before, like imagine that we have deposited some A tokens, like using the same, exactly the same function and exactly the same strategy that we mentioned before. We locked, for example, uni and a ETH. So we have ETH and uni deposited in the protocol. We want to borrow 100 DAI. What happens here is that we call essentially, we all still reference the DAI address. We have an amount, we have an interest rate mode, which will be 1 for stable debt and 2 for variable debt. Referral code is exactly the same as before, and the same meaning. On behalf of it is the same meaning as before, because as I mentioned before, we have credit delegation on the Aave protocol. So you can either borrow for yourself or you can allow someone else to borrow on your behalf, which is called the credit delegation, but it's something that we'll discuss later. There are some slides specifically for that. So yeah, you can borrow by just calling the borrow function, specifying the amount, the asset you want to borrow, interest rate mode, the referral code on behalf of. If the protocol does a certain pre-flight checks, and if everything works as expected, if you are within your borrowing power, if your assets are eligible to be considered as collateral, because not all the assets can be used as collateral, then you are allowed essentially to borrow the amount that you are specifying, and you will receive the amount automatically in your wallet, and you will start accumulating debt and interest from immediately after. Sorry. Okay, so of course, there is also a swap function, so you can swap between the rate loans, variable rate loans, and stable rate loans. And then you can decide whether at any point in time, whether, for example, if you believe your interest rate mode your debt is too high, then you can decide, for example, to swap to variable, or vice versa. If the stable rate drops to a point where you consider it competitive, then you can essentially swap automatically with only one transaction, and this executing this function to the other rate mode. The repay, of course, is the action of executing a payback of your loan. So again, it's pretty straightforward. You just, as before, of course, you need, if you want to repay 100 DAI, you have to have 100 DAI in your wallet, and you have to have approved 100 DAI to the protocol to take 100 DAI out of your wallet. And then you can call the repay function, specifying again the asset, the amount, the interest rate mode on behalf of, again, because you can also repay on behalf of other addresses. Imagine, for example, that you borrowed with address X, but you have your DAI on address epsilon. Then you can decide to use address epsilon to repay your debt on address X. Okay, then credit delegation. Essentially, as I mentioned before, when you deposit some collaterals, you also have a certain borrowing power, right? With credit delegation, you can decide whether or not delegate your borrowing power to third parties. With what that means is that you can decide in a similar way mechanism of the approval function for ERC20. You can decide to approve another wallet that potentially has no collateral deposited on Aave to borrow on your behalf. What that means is that when you borrow on behalf, you will receive the principal that has been borrowed, and the address on which you are borrowing, on which behalf you are borrowing, will essentially be accounted for the debt. So this is what the credit delegation is. It's essentially allowing third parties to draw liquidity from the protocol while taking ownership of the debt. Why I would do that? Multiple things. For example, I want to keep my, imagine for example, I want to keep the wallet where I keep the collateral and I keep my position off chain, but I want still be air gapped, for example. So in a cold wallet, but I want to I don't know, keep using the protocol while using a different wallet that is a hot wallet. I want the freedom to borrow and repay at any time I want. So I can just, for example, I can just prepare my position on the wallet, delegate to the wallet, the hot wallet that I actually want to use, and then like air gap the other wallet. So it's never connected to the internet, it's effectively a cold wallet, and use the hot wallet to which has received delegation to draw credit from the cold wallet and repay at any time. So this is just one of the things that this credit delegation allows, but you can also create a delegation system, for example, where you can decide to delegate credit to your friends or to another third party where you got a legal agreement with off-chain. So there are multiple things that can actually be built on top of that. How the credit delegation works. So, okay, here there are some bit no schemes, but it's not needed. I decide on which particular asset I want to give delegation to a certain wallet. In Aave, I didn't mention before, but maybe I should have mentioned it, that the debt is also tokenized. So when a person, it's like the debt of an address is not kept as a internal accounting in smart contract, but it's tokenized. So if you have a collateral and you draw 100 DAI of debt, you receive in your wallet the 100 DAI, but you also receive 100 debt DAI. This token that you receive, debt DAI, you cannot move it out of your wallet. You cannot do anything with it. The only thing that you can do is burn it through repayment. So that particular token actually keeps track of your debt position on the Aave protocol. So what happens under the hood when I delegate to someone is actually that the person, the delegatee that is drawing credit from the protocol receives the underlying. So if the delegatee is borrowing DAI, receives the DAI, and the delegator actually receives the debt token that tracks the debt position. So to be able to delegate credit to another address, I need first to receive the stable debt token address and the variable token address from the addresses provider, which essentially gives the token addresses. Then I can, of course, I can store the address of the borrower, which is the address of the delegatee that will receive the credit, the amount that I want to delegate, and then I call either on variable or stable debt token this function approve delegation that essentially tells, okay, this guy here, the borrower, can borrow using my borrowing power up to X, which is amount in way. So when approval is given, once approval is given, then the delegatee can actually go on the protocol and call the borrow function on behalf of, which is the delegator address that called approved delegation before, and the delegatee will actually able, which is message sender, of course, will actually able to draw credit from the protocol even if the delegate does not have any collateral. Then, like, you can, anyone can, of course, as I mentioned before, can repay the delegator debt, including, of course, the delegatee. So if the delegatee wants to repay the debt on chain, then he can just call the repay function by delegating to delegator address. Okay, then flash loans. Let me check quickly how much time I have. Okay, so the flash loans are like, they are now very well known and very much ingrained in the DeFi mechanics, but like, it's something that actually took traction only recently, and it's essentially leverages the capability of smart contract of the atomicity of transactions, right? So it's well known that when you execute a transaction, the transaction is atomic, so it's essentially everything that happens during the transaction will be completely reverted, like the transaction never happened if the transaction is not successful. Using this atomicity property of the transaction, essentially we came up with this idea of flash loans, where anyone can draw liquidity out of the Aave protocol without having any collateral, with the condition that the debt is repaid at the end of the same transaction. Of course, the duration of this particular loan is one transaction, which means that as long as the transaction is in progress, you can do whatever you want. But once the transaction is completed, the funds needs to be returned. Otherwise, the transaction will fail and everything that happened will be reverted. So it cannot be used by EOA. It cannot be used off chain. It can only be used by smart contracts. So of course, like it's quite a wide topic. There is a lot to talk about. So like we have some guides. Like afterwards, I will give you reference to all the developers guidelines and to all the documentation that we have. This one is specifically for flash loans, and it essentially showcases how to use the flash loans, what are the use case, and what you can build on top of it. Yeah, here is a bit of like a short recap of potential use case. You can use a flash loans to migrate liquidity between protocols. You can use flash loans for arbitrage. You can use flash loans for liquidations. You can use your flash loans to swap one A token to another A token without even leaving the Aave protocol. So imagine, for example, you have a DAI and you decide that you want to buy ETH and you want the ETH automatically deposited in the Aave protocol. Then you can use flash loan to do a flash loan of DAI, sell the DAI for ETH on DEX, for example, Uniswap, then deposit the ETH, and then use the original DAI that were deposited, withdrawing them and repaying the flash loan, and you end up with a ETH automatically in the Aave protocol. And there are a lot of different stuff, like another is like, yeah, repaying with the debt using your collateral is another thing. For example, if you are leveraging and you have you have used your collateral to actually leverage more of your collateral, then you can use a flash loan to sell your collateral on DEXs, and then use the amount sold to repay your debt on Aave, and then to repay the flash loan. And there are multiple, many more use cases that I think we can discuss at the end when we also list the Aave integrators. So here, I don't know how much time I have. Probably maybe I should stop here. Emily, what do you think?
Yeah, I'm sure a couple minutes wouldn't hurt. We might need to just channel some of these questions into the Discord chat.
Okay. So I will try to compress all of this in a couple of minutes, and then like if we can answer the questions in afterwards. Okay, so here it's a small breakdown of the examples that you will actually guys find in the documentation. So everything is in documentation. Essentially, flash loans. Here is in the code here that you see, it describes how to call the flash loan function on the lending pool contract. So preparing all the data that it needs to be passed to the flash loan function. And then like the proper flash loan execution requires the usage of a smart contract that inherits a certain interface. This interface exposes this function execute operation. And this actual action is called by the lending pool function once the funds are transferred. So for example, if you need to do an arbitrage, then you can do the arbitrage within this execute operation function. And at the end of this function, the funds will be automatically drawn from the contract that implements this execute operation. And then the governance, also here there is a lot to cover, but like I can point you guys, I can point you out to the documentation where everything is explained. Essentially, Aave has a pretty organic, pretty complex governance system. It's also very powerful. So the governance is completely open source and is meant to help even other decentralized protocols that they want to use a very flexible, very powerful governance. So anybody can fork. Of course, the code is completely fit to use. Anybody can fork it. Here is the architecture of the governance, which is also described in the documentation that I will refer afterwards. And then here is the process that is used on the Aave within the Aave community to submit ARC and IAPs, and then propose voting on chain and clean execution. I think like it's going to be a bit long to discuss all of this. So like just a few use cases of the Aave protocol: Curve, DeFi Saver, Furu Combo, Wire Finance, Aave Gochi, and a lot of more integrations: Wallet, Gnosis, Monolith, Jelly Swaps, Synthetics, 1inch aggregators, idle finance. There is a lot to unravel. The development environment, everything is in the public GitHub. And yeah, my time is expired. And yeah, Aave protocol JS for data formatting. And there is also a library on the same repo, which essentially exposes all the functions that you might want to access of the protocol off chain. So using, for example, Ethers or Web3 resources, and that's it. Thank you, everyone. Emily?
Yeah.
Yes.
Great. Thank you so much. You squeezed quite a lot of information into
Yes.
about a 35-minute session. Yeah, there's a couple questions in the chat. I mean, we could take a minute to take maybe like 2 questions, and then the rest I'm going to save and pull over to the sponsored Discord channel, and we'll ping you there where you can answer them. And everyone on this call, please have a look in that channel for responses from Emilio.
Okay, sounds great. Yeah, I'm going through quickly through the answers. I think I can handle in the
Perfect
afterwards.
Okay, great. Okay, nice. Thanks so much, Emilio, and thank you everyone for joining this session. We will see you in Discord.
Great.